Okay, so I'm sure everybody has experienced or dividing something by zero. Either in high school you want not to divide by zero. You're like, so why don't we divide by zero and get zero or something else? You're told that it's undefined. And in those times when you should punch that in your calculator, you're either told math error or undefined. There'll be an expression that will make students very bothered. Some people just feel that maybe it's just something mathematicians have brought up to just confuse our minds. In this video, we would want to take time and explore why a number divided by zero is undefined. So let's get right into what we have to talk about today. The first fundamental idea to appreciate from as early as primary school is that divisions are repeated subtractions. Just as you know, multiplications are also repeated additions. One thing you have to know in maths is that lots of things are just they're just rebranded, they're just glorified. Very simple things are given sometimes some complex names. So instead of saying subtraction for a very long time, lots of subtractions, we'll call it divisions. Instead of saying a lot of additions, we'll call it multiplications. There are lots of things in mathematics like that. Maybe let's look at our calculus. Instead of saying something changing, we'll coin a name for it and call it calculus. Or let's say factorials. A number multiplying itself, its smaller day gets to 1. We'll give it a name and call it factorials. It will look very big in your mind. So that's one thing to know. So divisions are just repeated subtractions. Let's say if I have a number like 15 divided by 5. You know that this answer is 3 without thinking so much about it. But this same thing is asking you a question that if we should subtract 5 from 15, how many times will you do it to get to 0? It's as simple as that. So it means that if I have 15 divided by 5, 15 minus 5 will give me 10. 10 minus 5 will give me 5. 5 minus 5 will give me 0. So it means that it's 3 because I've subtracted 5 3 times to get to 0. So divisions are also repeated subtractions. So beautiful. Now let's see if I have, what about if I'm dividing by 0? Let's think about it. If I have 15 divided by 0, it's asking me that how many zeros will I take from 15 to get to 0? What do you think? That will be infinity. I can be subtracting as many zeros as possible and still wouldn't get to 0. Can subtract 15 minus 0 will still give me 15 minus 0 will still give me 15 minus 0 will still give me 15. So I'll subtract an infinity amount of zeros from 15 to get to 0. So that looks like, wow, I've gotten the answer. Or just to say that, okay, it means that 15 divided by 0 is infinity. Why can't it be infinity? Let's think about it. Now, what would be 20 divided by 0? That would also mean that 20 divided by 0, from the assumption we just made, then 20 divided by 0 should also end up as infinity. However, there's one other thing to think about. When I have a number like this, 15 divided by, let me use, divisions are also expressed as fractions. So 15 divided by 5 is equal to 3. This also means that if I have this as my dividend divisor and then quotient, my divisor and my quotient should give me the dividend. So therefore, from this example, 5 times 3 should give me 15. Which makes sense. Now, if this is going to be true, then it means that 15 over 0 equals to infinity. It implies that infinity, 0 times infinity, should be equal to 15. Likewise, 20 divided by 0 equals infinity. Then it means that 0 times infinity should be equal to 20. And that's absurd. Doesn't really make a lot of sense. Two different, same values can give us two different answers. So it simply means that this gives us something to think about. It can't be infinity. Now, why do we have to settle on the fact that it's undefined? It now means that we can introduce the concept of limits. The idea of limits simply means that we are trying to get somewhere, but we'll really not get there. We're trying to do our best to touch something, but we wouldn't touch. That's what limits basically mean. So when I have, let's take the limits. So 1 over x, the limits as x approaches 0 of 1 over x. The limits as x approaches 0 of 1 over x. That would mean something like this. So I have 1, so the number, the numerator, denominator, don't mind my writing. And then the answer. So if I have, obviously it's just going to be 1, 1, 1, 1, 1. So I'm trying to approach 0 from the positive side. That will mean my denominators will be the first one. Let's take something like 0.1, 0.01, 0.001, 0.0001, 0.00001, 0.0001. I'm going to take limits of the same value. So we would have the first one to be 10, 100, 1,000, 10,000, 100,000. So this is taking a positive value, you get very big values, or taking it from the positive side. Now, if I'm taking the same thing from the negative side, taking limits as x approaches 0 from the negative side, I'll be doing this on a graph for you to really appreciate it. So just let me finish up with the table and then you figure it out. So the number, denominator, and then the answer. So 1, 1, 1, 1, 1, 1. It will be minus 0.1, minus 0.2, minus 0, minus 0.01, minus 0.001, minus 0.0001, minus 0.00001, minus 0.0. One in that order. That will give me the same values but still negated. Negative 10, negative 100, negative 1,000, negative 10,000, negative 100,000, negative 1 million. Good. Yeah, so if we should represent this on a graph, we'd have 3, 2, 1, values less than 1, 0.1, 0. Going down like that. So we would have minus 3, minus 2, 1. So if you have a number like 1 over 3, you'll have 0 point something, will be a value going like this. 1 over 2 will be 0.5. 1 over 1 will obviously be 1, so tally up with this one. 1 over 0.1 will give you 10. 1 over 0.01 will give you 100, will give you 1,000, will be having big values, and then we'll have an asymptote, meaning we'll be moving and we'll still never reach any value, so be going to positive infinity, going so high. Then over here from the negative side, it will still be coming this way, just the same concept as we have here. We minus 0.3 something, 333, minus 0.5, minus 1, minus 1, and then the rest will be going in that very big direction. So we have an asymptote somewhere here. So it means that a number divided by 0 is undefined because we can't have any fixed value. It's not going in any definite direction. It's going this way. The same number is also going like this. So the way to represent that is to say that a number divided by 0 is undefined. So see you in the next video. Bye for now.